So in the problem we solved yesterday with the rocket, right, that was launching something up and down, we had to find, we were given displacement or position s of t, and then we had to find speed. And we said that if you have the displacement function and you want to find speed, then it's just a straight derivative. Okay? So now, okay. Does everybody have their notes out? Okay. So that's what we did here. We were given the position function. We had to find speed and velocity, and that was just straight derivative. Okay. Now, take a look at this one. We have a particle moving along a line. Most, like all of these are going to be, a particle motion along a line. Okay, either going up or down, right or left. And remember what I said yesterday? We don't talk about right, left, up, down. We say positive and negative. Okay. All right. So a particle is moving along a line so that the position is given by this function here. So this is the position function, where s is measured in meters and t is measured in seconds. So that's important. S is measured in meters and t is measured in seconds. Okay? This is really helpful to highlight, underline, circle all of these important things so that later your eye just goes to the information that you want. All right, so first it says, find the displacement of the particle during the first 2 seconds. All right, displacement. We're not looking for velocity. We're not looking for speed. We're looking for displacement. And remember, when we talked about displacement, we defined it as final position minus initial position. Okay, at the very end, where was I? Compared to at the beginning, where was I? All right, so here, if it's during the first 2 seconds, all right, it means from t equals 0 to t equals 2. Okay, so we need to find s of 2 minus s of 1. All right, how do I find s of 2? What do I do? 0, sorry, 0. What would I do to plug it into S, right? So you plug it into S. When you plug 2 into S, it's 2 squared minus 4 times 2 plus 3. You end with minus 1. Minus, what's S of 0? Just 3. So this is equal to negative 4. Okay, so now you want the displacement. Physically, the displacement is from the very beginning to the very end. How much total distance are you away from where you started? So your displacement is negative 4 meters.
Wait, I thought displacement was a scalar.
Well, no. Distance is a scalar.
Oh.
Distance is a scalar. Displacement is not. So if it's negative 4 meters, if your displacement is negative 4 meters,
It'd be like
it means you are 4 meters in the negative direction. Okay? I know, but like yogurt. Okay, so now the average velocity, again, you're just going to refer to that page of formulas. The average velocity is final position minus initial position over the total time. So, and it says during the first 4 seconds, so that's going to be S of 4 minus S of 0 over 4 minus 0. And, okay. Huh? Displacement is just the numerator, S of 4 minus S of 0, and now you're dividing it by the total time. This is displacement over time. Okay? S of 4, it turns out, is 3, minus S of 0 is 3, over 4 minus 0. What is that? 0. meters per second. What does that mean? That your average velocity is 0?
You're just not changing speed. You're not changing speed.
You're not changing speed or direction.
Okay, so this object moved, right? From t equals 0 to 2, it had a displacement.
Bless you. Bless you. Thank you. Did someone sneeze? Yeah, Lauren sneezed. Oh, bless you. Thank you.
From t equals 0 to t equals 2, we know that it moved a total of, there was a displacement of 4 meters. All right? So what does it mean that the average velocity is 0? Your velocity, remember, okay, so the speed would not have been 0. The average speed would not have been 0. But remember, velocity is also speed and direction. So if you had positive velocity for some time and then negative velocity for some time, the positive and the negative would cancel each other out, but it doesn't mean that you weren't moving. Okay? All right. So here, the instantaneous velocity of the particle when t equals 4. All right, instantaneous velocity, that's v of t, which is s prime of t. Okay? So v of t is equal to, we're going to take the derivative, right? So that's 2t minus 4. Yeah?
Oh, and then the acceleration would be the derivative.
So v of 4, right? The instantaneous velocity when t equals 4 is v of 4, which is 2, right? V of 4 is how much? 4 meters per second. Yeah. Okay. So even though the average velocity over that time, it turned out to be 0, but at 4 seconds, it's got a positive velocity of 4 meters per second. Okay, the acceleration of the particle when t equals 4,
Isn't that S double prime?
it's s double prime, which is v prime.
Which is 2, isn't it?
So a of t is equal to 2, right? A of t is equal to 2. There is no variable in this. It's just a constant. What does that mean? No matter what the time is, the acceleration is what? 2. All right? That means it's got a constant acceleration of 2. So a of 4 is equal to 2 meters per what?
Second square.
Meters per second, which is meters per second squared. Now, what would be what's a of 10? 2. What's a of 0?
2.
Well, right. Okay. Describe the motion of the particle. At what values of t does the particle change directions? Okay? This is important. So for this, we need to take a look at v of t. Remember what we were doing yesterday? We said when it moved all the way up and then it was going to now change direction and move back down, there was a split second where the velocity was what? 0. So whenever it turns around, the velocity is 0 for that split second. In other words, whenever the velocity is 0, it's turning around. So what we have to do is look at when v of t is equal to 0. Okay? Because when the velocity is equal to 0, it's turning around. When it's turning around, the velocity is 0. Okay? So v of t is equal to 2t minus 4. We found that in part C. When velocity is 0, that means 2t minus 4 is equal to 0. So 4 is equal to 2t. T is equal to 2. That means at t equals 2, what happens? It changes direction. Okay, so let's take a look at the velocity. Okay? This is when time is 0. Okay? This is when time is 2. Okay? Take a look at the velocity. What's the equation for the velocity? What's the equation for the velocity? 2t minus 4. Okay, now, look at 2t minus 4. When t is between 0 and 2, let's say when t is equal to 1, if you were to plug 1 inside b, would you get a positive or a negative value? A negative value. If you were to plug in a value from the other region, greater than 2, would you get a positive or a negative value? Positive value.
Before it was 0, right?
Yes.
Like it cancels out.
So the velocity is negative here. The velocity is positive here. The velocity is 0 at t equals 2. Yeah. Okay. So that means it is moving in the positive direction from 2 to infinity. Okay? It's moving in the negative direction from what to what? Is there t equals negative infinity? When does time start?
0.
Time starts at 0 to 2. Sorry, hang on. 0 to 2. Okay. At 2, it's going to be open because at 2, what's the velocity? 0. It's turning around. It's in limbo. All right? Now, what about at 0? At t equals 0, it's a bracket. Okay?
Why is it infinity though? Isn't the whole thing only 4 seconds though?
No.
Like infinity means like any.
Hang on. I'll answer that question. It turns around at t equals 2. Now, t equals 4 is the farthest we checked in this problem. There is no information here of saying, you know, at what point this problem stops. Infinity, in this context, it's not the end of time. It's not, you know, like when the world ceases to exist. It's when this problem just decides that it's, you know, this particle just decides that it's not going to move anymore. For all intents and purposes, it's like a long time away. But, you know, so we just leave it that way. Okay? All right. More important stuff. Okay. Any questions on this? So now the important part here is how you would be able to tell the difference within between displacement and instantaneous velocity, right? So displacement and average velocity are final minus initial. Okay? Displacement and average velocity. Instantaneous velocity is just straight derivative. Acceleration, straight derivative. Okay? That's the purpose of this problem. Yeah.
Just to clarify, acceleration depends upon instantaneous velocity.
Correct.
Whereas, like average velocity and displacement like the opposite.
Right. Okay. So this, yeah. Average velocity is secant. Instantaneous velocity is tangent. So that's derivative. Okay. Take a look at this one. A particle P moves on a number line shown in part A. Right? So it's telling us, if it's defined like this, it's telling us that it's horizontal motion. It's going right or left. So notice in the problem before, it was just saying a particle is moving along a line. It didn't specify direction. So here, I didn't say it's moving left or right or up or down. I just said in the positive and the negative direction. In this case, it's visually specified that it's horizontal, so it's moving left and right. We can say that here. Do you guys see the difference? Okay. So part B shows the position as a function of time. Okay? All right. So number 1 says, when is P moving to the left? When is it moving to the right? When is it standing still? Okay? All right. So how are we going to figure all this out.
So would left be away from 0 and then right towards 0?
Uh-huh.
Can we slope the slope?
You can just look at the slopes. So, what would you say?
0 to 1 is moving to the left. Then from 5 to 6.
From 0 to 1, it's moving where?
I mean, right, wait.
Right, okay.
What was the question?
Okay, so when is it moving to the left and when is it moving to the right?
Okay, it's moving to the right from 0 to 1.
Why?
1 to 2.
Why is it moving to the right? Explain it.
Because it's going up.
Okay, so from 0 to 1, oh, hang on. From 0 to 1,
The slope is positive.
the slope is positive 2. If it's, okay, so what does the slope symbolize here? Velocity, okay? The slope symbolizes velocity. If it doesn't immediately come to you, all right, what is slope? How do you find what slope is? Slope is the y over the x, right? It's centimeters per second. That sounds like velocity to me, right? That's how I would know. So m is equal to 2. It's got positive slope. It's got positive velocity. It's moving in the positive direction.
Aren't they all moving in the positive direction?
Are they? So let's see. Here, what is m here? 0. What is m from in that other segment? Negative 4. So it's going from 2 to negative 2. So that's a distance of 4 over 1. So m is equal to negative 4. What about here? What about here? Negative 2. Okay? So, when is it moving to the left? Whoops, let me write it here. When is it moving to the left? It's when the slope is negative. Right? It's when the slope is negative. When is the slope negative? From 2 to 3. Where else? From 5 to 6. Okay? It's exactly that. When is it moving to the right? 0 to 1. Open or closed? And then open. Okay? When is it standing still? 1 to 2, 3 to 5. Yes. Hang on. When we have to graph the velocity, right, we're just going to go with the slopes as we did up there. So from t equals 0 to 1, we have a slope of 2. The velocity is 2. It's got a constant velocity of 2. So it's, that should be a straight line. Yeah. Uh-huh. Do you guys mind if I move this up? Okay, now from 1 to 2, what is the slope? 0. So remember, closed at the ends, open everywhere else. And then 2 to 3, negative 4. And then what else? 3 to 5 is 0. Okay. And then what else? Negative 2? Yeah. Negative 2 is here. Close. Okay, so this is the velocity. Now I need to graph speed. What's the difference between velocity and speed? Elliot, yeah.
You put speed over time, you put velocity over time, and you put speed over time.
Is that true? What's the difference between velocity and speed?
Speed can be negative.
Speed does not have direction, so it can't be negative. Okay? So, so let me ask you this way. When, from 0 to 1, when the velocity is 2, positive 2, what's the speed? 2. When the velocity is 0, what's the speed? 0. When the velocity is negative 4, what's the speed? 4. It's traveling at a speed of 4, but there is no direction. In the velocity, it's traveling. Okay, so let me do this. 4. Okay, so take a look. That's an open circle, by the way. Here, okay, it's traveling at a speed of 4 in the negative direction. Here, it's traveling at a speed of 4. We don't know the direction. Okay? That's what it is. Of course, it makes sense. It's math. Okay? Now, 3 to 5, the velocity is 0. What's the speed?
0.
Okay? 5 to 6, the velocity is -2. What's the speed? Yeah.
Basically all the negatives.
All the negatives just become positive because you're stripping it of the sign. Okay? Remember, look here. Speed is the absolute value of velocity. So the numerical value will stay the same. You're just stripping it of the sign. Does that make sense?
Yes.
Yeah? Okay. So that's where this ends.